You know, um, when we think about modern agriculture, for those of you listening who aren't farmers, we usually picture this incredibly controlled environment. I mean, it's a lot like engineering a high-performance sports car, right?
Right, yeah. Every single variable is optimized.
Exactly. You give this biological machine, the exact right fuel, you keep it at the perfect temperature on a smooth track, and it performs beautifully.
It's a system built entirely on predictability. I mean, we have essentially, engineered the variability totally out of the equation.
Right. But then imagine taking that highly tuned, low clearance sports car and just dropping it onto a jagged, freezing, completely oxygen deprived mountain pass in the Himalayas.
Yeah, that's a disaster waiting to happen.
Total disaster. Suddenly, all that specialized engineering becomes this massive liability. The engine stalls, the frame cracks, and the whole system just completely shuts down.
Because the machinery simply isn't designed for the reality of that terrain. It's too delicate.
And that environmental mismatch is exactly what's happening in the Trans-Himalayan region of Ladakh. For anyone trying to run a commercial poultry farm up there, it's essentially playing the game on the absolute hardest difficulty setting.
Oh, without a doubt.
So today's deep dive is going to explore this really fascinating scientific paper that investigates exactly how we can keep those biological sports cars from completely breaking down.
Right. And, to really appreciate the scale of the challenge here, we have to look at the compounding environmental stressors in this region. Because it's not just one thing. First, there is severe hypobaric hypoxia.
Right, the low oxygen.
Exactly. The atmospheric pressure is so low that there is a drastic reduction in available oxygen. So, every breath delivers just a fraction of the oxygen you'd get at sea level.
Which is brutal on its own. But plus, the temperature swings are just wild. I was reading the research, and it notes it goes from a blistering, plus 35 degrees Celsius in the summer
Yeah, which is incredibly hot.
to a bone-chilling minus 35 degrees Celsius in the winter. And then you add in, intense ultraviolet radiation, incredibly low humidity, and this severe scarcity of quality fodder.
It's really the perfect storm.
It is. It's no wonder this environment absolutely wrecks poultry productivity. I mean, it compromises their immunity, spikes mortality rates, and creates this almost insurmountable economic burden for the local farmers who are just, trying to make a living.
Yeah, it's devastating for the local economy.
Which brings us to the core of the problem, right? The modern broiler chicken itself. I just have to ask, why is this specific bird so uniquely terrible at handling this environment? I mean, birds fly over the Himalayas all the time.
They do, yeah.
So why does this particular chicken just crash and burn?
Well, it really comes back to your sports car analogy, actually.
Exactly.
Because modern broiler chickens, they've been selectively bred over decades for one primary trait, and that is extremely rapid growth.
Okay, so they're built to get big fast.
Exactly. They're designed to pack on muscle mass as quickly as biologically possible. But that rapid growth, requires a massive metabolic engine running at full tilt all the time.
Right. And big engines need a lot of air.
Precisely. Which means their baseline oxygen requirements are just incredibly high. So even on a good day, at sea level, they are burning through oxygen fast.
Wow, okay.
And that massive metabolic engine comes with a fatal flaw when you move them. They are fundamentally susceptible to oxygen deficiency. So when you put them in a hypoxic environment, like a farm at 3,500 meters altitude.
Their biology just starts to unravel, right?
Exactly. At the cellular level, the lack of oxygen directly disrupts their mitochondrial respiration.
Okay, wait, let's unpack the cellular level thing, because I want to make sure you, the listener, can really picture what is happening here. Let's think of the broiler cells as a massive high production factory.
Like that.
Right. And oxygen is the critical fuel that keeps the conveyor belts moving and the machines running smoothly. So under hypoxic conditions, when that fuel supply gets choked off, the machinery doesn't just quietly stop, does it?
Oh, no, not at all. It starts violently misfiring.
Misfiring, right.
Yeah, the energy production cycle gets backed up, and the biological machinery basically starts grinding its gears. It starts spitting out these dangerous, highly reactive molecules all over the factory floor.
And those are the ROS, right.
Exactly. In biology, we call these reactive oxygen species, or ROS. They are they're unstable molecules that are missing an electron. So because they're unstable, they aggressively steal electrons from anything around them.
They're basically like wild sparks flying off a broken machine, just burning holes in whatever they touch.
That is literally a perfect way to visualize it. And unless These harmful ROS molecules are neutralized by antioxidants.
Which are like the microscopic fire extinguishers.
Yes, fire extinguishers. Unless they step in, the sparks run rampant. They destroy proteins, they oxidize the lipids that make up the cell walls, they shred DNA strands, and they basically just melt down the cellular membranes.
Wow.
That is what oxidative stress actually is. The factory is burning down from the inside out because the machinery is misfiring from a lack of oxygen.
Okay, but let me push back here for a second. If oxidative stress from, low oxygen is the main issue, and we just need microscopic fire extinguishers, why go through the massive trouble of finding a complex biological solution?
William?
Well, why not just dump a bunch of synthetic vitamin C, which is a known antioxidant, into their water and just call it a day?
Well, it is a very logical question, but it misses the systemic nature of the problem.
Uh-huh.
A simple antioxidant like vitamin C, it only does one job, right? It neutralizes those sparks.
Okay.
But it doesn't fix the underlying machinery. It doesn't help the bird adapt to the freezing cold or the low humidity or the massive UV radiation.
Right, the environment is just too hostile.
Exactly. The environment in Livestock is triggering a cascading multi-system failure in the birds. To fix that, you don't just need an antioxidant, you need an adaptogen.
Ah, an adaptation, meaning like something that literally helps the organism adapt to widespread stress.
Yes, exactly.
And to find that, the researchers didn't look in a chemical lab, they looked at a local resident.
They did. They turned to a plant that has basically mastered this exact environment.
Hmm.
It's called Rhodiola imbricata.
I was reading about this plant in the paper, and it is just incredible. It's this alpine herb that naturally thrives in the Trans-Himalayan cold desert. And it grows at brutal elevations, like well above 5,000 meters.
It's amazing.
Just think about that for a second. It sits up there in the freezing cold, bathed in UV radiation with barely any oxygen, and it doesn't just survive, it thrives.
And, its resilience hasn't gone unnoticed by humans either. For centuries, local communities in these high-altitude regions have used rhodiola in their traditional medicine.
Oh, really?
Yeah. It's been used to improve human endurance, reduce severe fatigue, and help people adapt to the overwhelming stress of high altitude. It is a true adaptogen. It's capable of increasing broad-spectrum resistance to multiple environmental stressors all at once.
So we know the plant has these, like, chemical shields in a vacuum, but biology is messy.
Buried in this.
If you take an ancient mountain plant and put it into a hyper-engineered modern chicken, do those biological softwares even speak the same language? Like, how did the researchers actually bridge that gap? Because they didn't just toss a salad into the chicken coop, obviously.
Right. No, they definitely didn't do that. Harnessing that biological software, as you called it, requires a very specific pharmacological extraction. So first, the researchers collected the roots of the plant from a location called Changla Top in Ladakh,
Okay.
which is at a staggering altitude of 5,330 meters.
Wait, 5,330 meters. That is nearly 17,500 feet. Just gathering the materials sounds like a major mountaineering expedition.
It truly is. I mean, just getting the plant is hard work. But once they had the roots, they washed them, dried them in the shade to preserve the delicate compounds, and then ground them into a fine powder.
And then they extracted it.
Yes, using a process called sock sled extraction.
Okay, I've heard of sock sled extraction before, but how does it actually work in this specific context?
Think of it like brewing the world's most intense, continuous pot of coffee.
Okay, I can picture that.
They place the plant powder in a specialized glass apparatus, and they use a solvent, in this case 60% ethanol. So the solvent is heated, the vapor rises, condenses, and drips down through the powder, dissolving the active compounds.
Just like hot water through coffee grounds.
Exactly. But instead of just passing through once and being done, the sock sled apparatus continuously recirculates that warm solvent through the plant material. And they do this for 24 to 48 hours.
Wow. Wait, why use 60% ethanol specifically, and why brew it for so long?
Well, ethanol is brilliant for this because it's a polar solvent. That means it pulls out both water-soluble and fat-soluble compounds, which gives you a complete, full-spectrum extract.
Oh, I see.
And the 24 to 48-hour time frame just ensures they're pulling out all the deep, complex medicinal compounds hidden inside the cellular structure, not just the easy surface-level nutrients.
That makes sense. And to prove what they actually managed to extract, they ran it through a machine called high-performance liquid chromatography, right? HPLC.
Yes, HPLC.
Which is basically a highly advanced chemical fingerprinting tool. So what did that fingerprint actually show them?
The HPLC confirmed the presence of two major bioactive powerhouses in the extract, salidroside and p-tyrosol.
Salidroside and p-tyrosol.
Yeah.
Okay.
And in the scientific literature, both of these specific phenolic compounds are famous for their intense antioxidant, adaptogenic, and immunomodulatory properties. They are literally the molecular shields the plant uses to survive the mountain.
That is so cool. And that leads us to the actual experiment, the real test. The researchers designed this rigorous 42-day trial.
Right.
They took 210 one-day-old broiler chicks and randomly divided them into 7 distinct groups.
7 groups.
You had one control group that just got normal drinking water and a standard diet. Then they had 6 treatment groups that received the rhodiola extract mixed directly into their drinking water, but at escalating doses.
Right. They tested a whole range.
Yeah.
It was 100, 150, 200, 300, 400, and all the way up to 800 milligrams of extract per kilogram of the chicken's body weight.
Now, my initial thought when reading that was, okay, the 800 milligram group is obviously going to do the best. More chemical shield equals more protection.
Right.
But that wasn't the case at all.
No, it wasn't. The 400 milligram per kilogram dose was the absolute winner. By day 42, those birds had significantly higher body weights compared to the untreated control birds, and even compared to the 800 milligram group.
But why wouldn't the highest dose work the best? It just seems totally counterintuitive.
I know it does. But it comes down to a pharmacological concept called hormesis.
Hormesis.
Yeah, which creates what we call a U-shaped curve. So adaptogens work by introducing a tiny beneficial amount of stress to the body, which then triggers the organism to strengthen its own internal defenses.
Oh, kind of like lifting weights to build muscle.
Exactly. The 400 milligram dose was the perfect workout. The 800 milligram dose, however, was like trying to lift way too much weight. It overwhelmed the system rather than stimulating it.
That is a massive aha moment. So the 400 milligram dose hits that biological sweet spot.
Perfectly.
But looking at the data, I noticed something else crucial about their growth. It wasn't just about the chickens eating more food and getting bigger. It was about their biological efficiency. And that was measured by something called the feed conversion ratio, or FCR.
Yes, XCR is perhaps the most important metric in commercial agriculture, period. It measures the amount of feed required to produce 1 kilogram of body weight.
Right. And for our listeners, I like to think of FCR exactly like the fuel efficiency in your car, like your miles per gallon.
That's a great analogy.
If a car gets better gas mileage, it goes further on the same tank of gas. Well, these birds in the optimal 400 milligram group required significantly less feed to produce their body weight.
Which is huge.
Yeah. They had the absolute best FCR in the entire trial while maintaining a similar total feed intake to the other groups.
Which means their bodies were utilizing the nutrients way more efficiently, instead of burning all those calories just to stay warm and fight off the massive environmental stress.
They're going to keep the factory from burning down.
Exactly. Their biology allowed them to partition that energy into actually building muscle.
And for a high-altitude farmer, that improved FCR directly translates to higher profitability. I mean, feed is expensive, especially when you have to literally truck it up a mountain pass into the Himalayas.
Oh, absolutely. But, beyond profitability, we have to look at the harsh reality of this environment. Did this extract actually keep the birds alive?
Right. Survival is kind of the ultimate metric. What did the mortality data look like?
Well, the untreated control birds, the ones facing the elements with no biological shield, they suffered the highest mortality rate at 13.33%.
Wow. That is a brutal loss rate for a short, 42-day cycle.
It is devastating for a farmer.
Yeah.
But in the groups receiving the rhodiola extract, mortality plummeted.
Really? How much?
In several dosage groups, including that optimal 400 milligram group, mortality dropped significantly. And in a couple of the groups, mortality was literally 0%.
Wait, 0? Going from a 13% death rate to 0 just by adding a plant extract to their water is mind-blowing.
It's incredibly effective.
But how did the researchers, prove what was happening microscopically? Going back to our factory analogy, how did they prove that the plant was actually extinguishing those dangerous ROS sparks?
They analyzed the bird's blood plasma using 3 very specific antioxidant markers.
Okay, lay 'em on me.
First is total antioxidant capacity, or TAC.
TAC.
Got it. This essentially measures the overall fire-extinguishing capability circulating in the blood. And in the treated birds, the TAC significantly increased.
So the factory had successfully recruited a bunch more firefighters.
Exactly. You've got more firefighters on site.
Love it. And the second test, the paper mentions something called DPPH.
Right. The second is called DPPH, free radical scavenging activity. DPPH is a synthetic brightly colored radical used in labs.
Okay, so it's a test chemical.
Yeah. When blood plasma containing antioxidants is mixed with it, the antioxidants disarm the DPPH molecules, and the color actively fades.
Oh, that's clever.
Yeah, so by measuring that color change, researchers can see exactly how effectively the plasma is neutralizing those missing electron sparks. And the scavenging activity was significantly higher in the rhodiola groups.
So they proved the extinguishers were actively working in real time. But what about the third marker? Did they check if any damage had already been done to the factory walls?
They did by measuring a compound called malondialdehyde, or MDA.
MDA, what is that exact?
MDA is a toxic byproduct that is only created when lipid peroxidation occurs,
Which mean?
which means those sparks successfully attacked and damaged the fat molecules in the cell membranes. It is the ultimate chemical signature of tissue damage.
Ah, so it's the ash left over from the fire.
Exactly. And in the treated birds, MDA levels plummeted. The lowest MDA levels were recorded in that sweet spot 400 milligram group, proving the cellular membranes were actively protected.
All right, so they grow faster, they use fuel better, and their cells aren't tearing themselves apart.
Yep.
But biology is totally interconnected. What happens to the overall long-term health of the animal? Specifically, the immune system and the major organs. Because survival is one thing, but health is another.
That's a great point. Let's group these findings, starting with the immune system, because the systemic benefits here are profound. The blood work showed total protein and globulin levels went up significantly in the treated birds.
And globulins are the primary building blocks of antibodies, right?
Correct. So the chickens were literally building a stronger, more robust immune defense. But the study goes even deeper than that, down to the actual communication signals of the immune system, the cytokines.
Right, cytokines. They act like the body's internal text messaging system coordinating the immune response. So what did the extract do to those messages?
This is where the biochemistry of the salidroside compound really shines. The researchers found that a cytokine called interleukin-2, or IL-2, increased.
And what does IL-2 do?
IL-2 promotes cellular immunity. It's basically a call to arms for targeted defenders.
Okay, good.
But simultaneously, a different cytokine called interleukin-6, or IL-6, decreased.
Why is decreasing IL-6 so critical here?
Because IL-6 triggers widespread systemic inflammation, which is highly damaging over time. Salidroside actually downregulates inflammation at the genetic signaling level.
Wow.
Yeah, it does this by suppressing a pathway called NF-kappa B.
Wait, I've seen NF-kappa B mentioned in other biological studies before. How does that pathway actually work in this context?
Think of NF-kappa B like the master fire alarm in the cell's control room. When the severe environment pulls that alarm, it triggers a massive inflammatory response to fight off perceived threats.
Which burns a ton of energy and causes damage.
Exactly. Salidroside essentially puts a lock on that alarm box. The plant extract acts like a highly sophisticated traffic cop, telling beneficial immune cells to multiply, while telling the damaging inflammatory response to stand down.
It is fundamentally reprogramming the immune response. That is wild.
It really is.
But I have to ask, anytime you introduce a potent foreign compound into a biological system, you risk toxicity, right? Especially in the liver, which has to process absolutely everything. Did this powerful extract actually harm their organs?
The researchers checked for exactly that. They measured AST and ALT. These are liver enzymes that normally live securely inside healthy liver cells.
So if the liver is healthy, those enzymes just stay put.
Exactly. When liver cells are damaged or stressed, their cell walls break down, and these enzymes leak out into the bloodstream.
Okay, and what did the blood work show?
In the rhodiola-treated groups, both AST and ALT levels in the blood actually decreased.
Oh, wow.
Right. This proves the extract is completely non-toxic at these doses and is in fact hepatoprotective. It actively reinforces the liver cells, preventing them from leaking under stress.
That is incredible. And as a bonus to all this, their overall physiological stress seemed to drop too. I know the study measured their lipid profiles and blood glucose. How did those look?
Remarkably healthy, actually. The bad cholesterol, the LDL and total triglycerides, went down, while the good cholesterol, HDL, went up.
Nice.
Furthermore, lower blood glucose is a very strong indicator of reduced physiological stress. When an animal's freezing and oxygen deprived, its body floods with glucocorticoid stress hormones.
Which spike blood sugar to provide emergency energy, right?
Exactly. So lower glucose levels suggest the adaptogen is keeping the bird's endocrine systems remarkably calm despite the environment.
Man, let's step back and summarize this incredible journey for you listening. You start with the Trans-Himalayan desert that creates this beautifully brutal, hostile environment for farming. You have modern broiler chickens that are biologically vulnerable, suffering massive cellular level damage, oxidative stress, failing immunity, and high mortality.
Right.
But by looking to a native plant, Rhodiola imbricata, researchers found a solution. By utilizing a highly specific extraction process and finding that perfect 400 milligram U-shaped curved dose, they provided these birds with a natural chemical shield.
A very effective one.
Yeah, it boosted their growth, maximized their feed efficiency, armed their immune response, and extinguished the oxidative fires in their cells, dropping mortality to nearly zero in some groups.
It is a remarkable synthesis of ancient botanical resilience and modern agricultural science. And for you listening, whether you're focused on agriculture, biology, or traditional medicine, this deep dive proves that nature often holds the biochemical keys to surviving the environments it creates. We are seeing a massive shift toward phytogenic or plant-based feed additives. They offer a sustainable, powerful alternative to synthetic chemicals and could honestly solve some of our most complex farming crises as global climates become more extreme.
It makes you reconsider the whole concept of a perfect machine from the beginning of our discussion. We spend so much time trying to engineer our way out of problems, trying to force the sports car up the Rocky Mountain.
Yeah, fighting against nature instead of working with it.
Exactly. But here's a final thought to mull over. If a simple plant that evolved to survive 5,000 meters up a freezing Himalayan mountain can fundamentally rewire a modern chicken's cellular response to stress, what other overlooked extreme climate plants are sitting out there right now?
That's a great question.
What other biological blueprints are hidden in the world's harshest deserts or deepest oceans, holding the software updates we need to solve our own most pressing agricultural or even human medical challenges? Maybe the perfect machine doesn't need to be rebuilt from scratch. Maybe it just needs the right adaptogenic armor. We'll leave you with that to think about. Keep diving deep.